Today we're going to learn how to count atoms in compounds. This is really important because when we start balancing reactions, we need to be able to have the same number of atoms for each element as reactants as we do products to fulfill the law of conservation of mass. So today we're going to learn how to count atoms both with subscripts and with coefficients to see what we get. Here are some rules for counting atoms. So number one, subscripts only refer to the atom that they are behind. So for example, here's H2S. That 2 right there is only referring to hydrogen. So there are 2 atoms of hydrogen and only 1 atom of sulfur in this compound. Coefficients. So number 2, coefficients apply to the entire compound. You multiply the coefficients and the subscripts. 2H2S. What that 2 in front as a coefficient is really saying is that you have 2 molecules of H2S. So if you would write them out, you would write H2S and H2S because you have 2 of those molecules. So the atoms of hydrogen and the atoms of sulfur. There are 4 atoms of hydrogen because there are 2 molecules of H2S and each molecule has 2 hydrogens. So 2 times 2 equals 4. And sulfur, we're assuming that there's at least 1 because we wrote the S. So that means that there has to be at least 1 atom of sulfur in each molecule. And we have 2 molecules, which means 2 times 1 is 2. Remember that if there isn't a subscript behind an element, you assume that there's only 1 atom of that element. Otherwise, why would we write it? Next up, parentheses. Number 3. If elements or compounds are inside of parentheses, then the subscript behind the parentheses applies to everything inside. Okay, this is just like math. So here we have Ba parentheses OH in parentheses 2, or barium hydroxide. So how many atoms of barium, oxygen, and hydrogen are there here? Well, let's look at barium first. So if you notice, there's no subscript after barium, and that 2 outside of the parentheses doesn't apply to barium because it's not inside the parentheses. So there's only 1 atom of barium. Now let's look at oxygen and hydrogen. So inside of the parentheses, there's only 1 atom of oxygen because it does not have a subscript. But that 2 on the outside of the parentheses means that you have 2 OH ions, or 2 hydroxide ions for every 1 barium. So that means that there are 2 atoms of oxygen and 2 atoms of hydrogen for the same reason. All right, let's do some practice. Let's start you off easy. MgCl2, or magnesium chloride. How many atoms of magnesium and how many atoms of chlorine are there here? So see if you can figure this one out. Okay, you got it? All right, there's 1 atom of magnesium because there is no subscript after magnesium. And there are 2 atoms of chlorine because chlorine has a subscript too. How about this one? Al2S3. How many atoms of aluminum and how many atoms of sulfur are there in aluminum sulfide? You got it? There are 2 atoms of aluminum because of the 2 subscript after Al, and there are 3 atoms of sulfur because of the 3 subscript after the S. All right, let's do some more. H2SO4, this is sulfuric acid. So how many atoms of hydrogen, sulfur, and oxygen are there here? All right, there are 2 atoms of hydrogen because of the subscript 2 after the H. There's only 1 atom of sulfur because sulfur does not have a subscript, so we assume there's only 1. And there are 4 atoms of oxygen because of the 4 after the O. Okay, how about this one? CH3OH. This one's a little trickier. So how many atoms of carbon, hydrogen, and oxygen are there? You think you got it? Okay, there's 1 atom of carbon because it does not have a subscript, so we assume there are 1. There are 4 atoms of hydrogen because the H3, and there's another H with the hydroxide ion, so it's OH there. So together there are 4 atoms of hydrogen, and there's only 1 atom of oxygen. All right, this could get a little tricky. Here we go. Ca3 parentheses PO4 parentheses 2. How many atoms of calcium, phosphorus, and oxygen are there? So pause the video and see if you can solve it. Okay, do you have an answer? There are 3 atoms of calcium because of the subscript of 3. Now for phosphorus and oxygen, we have parentheses to contend with. So the PO4 is the phosphate ion. So inside of the parentheses, there's only 1 atom of phosphorus. But what that 2 as a subscript outside of the parentheses is telling us is that we need 2 phosphate ions for every 3 atoms or ions of calcium. So that means that we have 2 atoms of phosphorus because 2 times 1 is 2. Oxygen, there are 4 oxygens inside of the parentheses, but you have 2 sets of those parentheses. So 4 times 2 is 8. So let's hope you got it right. Let's try another one. Al2SO43. This is aluminum sulfate. So pause the video and see if you can figure out how many atoms of aluminum, sulfur, and oxygen there are. Okay, you got it? Okay, there are 2 atoms of aluminum because of the subscript 2. And then now we have parentheses, the same thing that we had before. Inside of the parentheses, there's only 1 atom of sulfur. But that 3 as a subscript outside of the parentheses is telling us that we have 3 sets of that sulfate ion. So 1 times 3 is 3. There are 3 atoms of sulfur. Now let's look at oxygen. Inside of the parentheses, there are 4 atoms of oxygen because each sulfate ion has 4 oxygens. But we have 3 sets of sulfate. So 4 times 3 is 12. All right, how about this one? 2Mg3 parentheses BO3 parentheses 2. This is magnesium borate. So how many atoms of magnesium, boron, and oxygen are here? So pause the video and solve. Okay, you think you got it? There are 6 atoms of magnesium because the 2 as the coefficient is telling us that we have 2 molecules of magnesium borate. So if we were to write it out, you would write out Mg3BO3 2 twice. So there are 6 atoms of magnesium because 2 times 3 is 6. Now if we look at boron, here we've got subscripts, coefficients, and parentheses, okay? So boron only has 1 atom because it doesn't have a subscript. But outside of the parentheses, we have 2. So within 1 molecule of magnesium borate, there are 2 atoms of boron. But since we have 2 molecules, or the 2 is written as our coefficient, 2 times 2 is 4. Lastly, oxygen. There are 3 oxygens inside of the parentheses because the borate ion has 3 oxygens. But outside of the parentheses is the 2. And that 2 is telling us that we have 2 sets of the borate ion. So 3 times 2 is 6. So in 1 molecule of magnesium borate, we have 6 oxygens. Okay, but we have 2 molecules. So 2 times 6 is 12. So there are 12 atoms of oxygen. Now what I want you to do is you have a practice page. So work on that and bring your questions to class. Look, Mom, it's carbon tetrafluoride. CFFFF, because the C is the 1 and then the tetra is the 4, so there's carbon tetrafluoride. Let's hope this isn't your report card. Thanks, guys.